Welcome to a journey into the shadowy depths of the universe, where one of humanity's greatest questions, are we truly alone in this boundless cosmos, once again stirs restless hearts across generations. Perhaps, at last, we stand at the very edge of the answer long dreamed of. Have you heard of James Webb, our new guardian of the galaxy, the all-seeing eye that pierces the deepest night? Today, James Webb has carried humanity closer than ever before to a discovery that could shake the very foundation of our world. K218b, a distant, alien world, suddenly shining brighter than 1,000 icy points of light, becoming the epicenter of our hunt for evidence of life beyond Earth. What makes K218b so special? Because within the misty veil of its atmosphere, James Webb has found something rare and haunting. Water vapor, methane, and even the elusive dimethyl sulfide, molecules that do not just appear by chance. These may be the biological signatures humanity yearns for, the whispered clues from the universe that life, in some form, might exist, quietly and mysteriously, out there. Armed with the most advanced space technology ever crafted, James Webb is not just a telescope. It is a sentinel of galactic secrets, leading humanity to the frontier of understanding. Are you ready to step beyond the threshold, to venture into the enigmatic world of K218b? If it were you, how would you feel standing at the boundary between what is known and the secrets yet unrevealed? Join us as we push onward, diving deeper into the vast cosmos, where questions that have haunted humanity for generations still await their answer. Have you ever wondered what enables humanity's gaze to reach the very edge of the universe? We, mere specks adrift in the cosmic sea, have always yearned to see the mysteries out there more clearly. And now, the magical eye of technology, the James Webb Telescope, or JWST, was born to turn that longing into reality. For decades, Hubble has served as a mythical window, unveiling breathtaking portraits of the universe and captivating millions of souls. But even the mightiest stars have their limits. That's when James Webb emerged, carrying the mission to bend the boundaries of our understanding and fling wide the doors to sights no one has ever seen. What makes JWST extraordinary is not just its colossal mirrors, but its cool screen. A multi-layered masterpiece of engineering, as vast as a tennis court, stretching itself to block the relentless heat from the sun, earth, and moon. Thanks to this miraculous shield, James Webb can cool to incredibly low temperatures, sharpening its senses to catch the faintest whispers of infrared signals streaming from distant celestial bodies. These signals are the golden keys to unlocking the secrets of exoplanets like K218b. Did you know that visible light can be swallowed or scattered by the dust of space, while infrared waves possess the strength to pierce through every foggy barrier, returning to us images clearer and sharper than ever before? If it were you, how would you feel knowing that JWST is not just a telescope? It is the eye that pierces the night, lifting the cosmic veil so that humanity can gaze upon what no one ever dared to dream. What would you think if you realized you are a part of this very journey? It is not just an achievement. It is a revolution in the way we observe and unravel the secrets of distant worlds. So what wonders await us when James Webb turns its magical gaze toward K218b, a planet drifting quietly 124 light-years away in the constellation Leo? K218b is not simply a cold stone lost in the cosmic sea. Have you ever heard of the Goldilocks zone? It is the fabled region where ideal living conditions converge, not too hot, not too cold, where liquid water can exist and life may blossom. K218b orbits its parent star, K218, resting right in the heart of that dream zone. But what sets it apart from all the other planets in similar orbits is that it is not just another ordinary rocky world. K218b belongs to a new class scientists call Hycean world. These Hycean planets, cloaked in hydrogen-rich atmospheres and covered by boundless oceans, open a new frontier in our quest for life beyond Earth. Here, the conditions are thought to resemble those around the hydrothermal vents deep within Earth's oceans, places known to nurture astonishing forms of life. Recently, observations from James Webb have unveiled mesmerizing secrets within K218b's atmosphere. From water vapor to methane, every signal seems to whisper the possibility of an undiscovered ecosystem. If it were you, what would you think knowing that, at the very edge of the universe, worlds full of hope may be hiding? Would you choose to believe in miracles, or remain skeptical before mysteries left unsolved? Scientists have even detected traces of dimethyl sulfide, a rare signal found in abundance only where life flourishes on Earth. The atmosphere of this distant world is like a cocktail, blended from mysterious elements and compounds, perhaps able to nourish life, or at least a form of existence humanity has never imagined. This discovery has sent a tidal wave of excitement through the scientific community, leaving every researcher restless and eager, all silently asking, could this be the missing piece to unlock the secrets of life beyond Earth? Researchers, like children before a box of magical gifts, cannot hide their thrill and curiosity as they debate the impact of these findings on astrobiology and the broader quest to understand the true essence of life in the boundless universe. Could a Hycean world with such an extraordinary atmosphere as K218b be the golden key to mysteries long kept from us about alien life? If it were you, would you dare to believe that one tiny difference in an atmosphere could rewrite the entire history of astronomy? What would you do if you realized that, right at this very moment, humanity is standing at the threshold of a new era? Exploring exoplanets is a journey both challenging and richly rewarding, where every mysterious layer of atmosphere reveals a new chapter in the cosmic story. K218b, with its perfect position in the habitable zone and its captivating atmospheric cocktail, stands as living proof of wonders far beyond our imagination. While Earth's atmosphere is a symphony of nitrogen, oxygen, and scattered impurities, K218bi paints an entirely different portrait. The hydrogen-rich atmosphere of this exoplanet, laced with traces of water vapor, methane, and perhaps even dimethyl sulfide, truly forms a treasure trove of scientific wonders. It is almost unimaginable. Humanity striving to decode a world over 100 light-years away, relying only on the faint glimmers of light slipping through its distant atmosphere. Have you heard of spectroscopy? It is the secret art astronomers use to unlock the fingerprints of molecules. Each type of gas absorbs light at its own wavelength, etching a hidden map only the most patient souls can unravel. Thanks to the night-piercing vision of James Webb, especially its mid-infrared instrument spectrograph, known simply as M, we are now able to reach wavelength ranges that were once out of grasp, discovering molecules that seemed forever shrouded in cosmic darkness. The presence of methane and the lack of ammonia in K218b's atmosphere have sparked a wave of captivating speculation. Could this place be sheltering a new form of life? On Earth, methane is often born from life itself, from tiny microbial engines to vast living ecosystems. If it were you, what would you think knowing that a single, minuscule molecule appearing on a world 100 light-years away can set the hearts of millions of scientists trembling? Would you dare believe that every beam of light skimming across K218b's atmosphere is whispering secrets unknown to anyone? Or would you choose to hold on to your doubts, waiting for another miracle to unfold? K218b throws open a rare gateway for human imagination, a place where life might flourish in seas of hydrogen, a realm entirely foreign to anything we have ever known. The very makeup of K218b's atmosphere hints at the presence of a subsurface ocean, like a secret heart of water beating quietly beneath its surface. This discovery stirs thrilling new questions about the miraculous interplay between atmosphere and hidden ocean, about how these restless dynamics might entirely reshape a planet's potential for life. So could that atmosphere be the key to a new understanding of what makes a world habitable and of life beyond Earth itself? When we picture life, we so often confine ourselves to visions of Earth-like worlds, lush, sun-dappled, and familiar. But the truth is, life finds a way in places our imaginations could never dream. Studying extremophiles, those courageous, extreme life forms that thrive in hostile, unforgiving environments, sparks new hope in our quest for life among the stars. Deep in Earth's oceans, hydrothermal vents gush hot, mineral-rich water, creating a world of darkness, untouched by sunlight, yet bursting with fierce vitality. Extremophiles such as thermophiles and acidophiles flourish there, defying everything we thought we knew about what life requires to survive. Could such resilient creatures exist on alien worlds like K218b? Could its hydrogen-rich atmosphere nourish forms of life utterly different from anything we have ever imagined? If it were you, would you be ready to change your perspective on what life truly means? K218b offers unique conditions for life forms never before explored. On Earth, there are tiny microbes called methanogens, artists that create methane in oxygen-free environments. If the methane in K218b's atmosphere truly has a biological origin, we might be gazing at a world where hydrogen-loving extremophiles quietly flourish, thriving in secret. The study of extremophiles not only broadens the boundaries of where life can exist, it compels us to rethink every ecological limit in our quest for life beyond Earth. From the fiery acid rivers of Rio Tinto in Spain to the frozen tundra of Siberia, life on Earth has found a way to adapt and thrive in the harshest corners. This unexpected diversity inspires humanity to boldly redefine biological frontiers, to dream of alien life forms in places once thought impossible, where the unimaginable becomes reality. With the possibility of a subterranean ocean and a hydrogen-rich sky, K218b stands as a natural experiment, the perfect setting for exploring extremophiles in an exoplanetary environment. Who knows, perhaps in that distant place, K218b is nurturing its own unique life warriors, adapting to harsh conditions and quietly etching their name into the story of the cosmos. If extremophiles do exist on K218b, what might their evolutionary journey look like? On Earth, life began with simple, single-celled organisms, slowly rising to become more and more complex. What would you think if, one day, in that far-off world, the same journey unfolded, giving birth to creatures beyond our wildest imagination? If this cosmic story has touched your imagination, don't hesitate to hit the like button, share your thoughts in the comments below, and spread the wonder of discovery by sharing this video with others. And remember to subscribe, so you'll never miss a step as we continue unraveling the universe's greatest mysteries together. Could that evolutionary process unfold on other worlds too, given enough time and the perfect conditions? One of the most fascinating aspects of studying K218b's atmosphere is the potential presence of dimethyl sulfide, or DMS. On Earth, this compound is often produced by tiny marine plankton and is considered a highly promising biosignature. But could its presence on an exoplanet like K218b truly be proof of life beyond Earth? In Earth's oceans, DMS is created by phytoplankton and plays many crucial ecological roles. It's a compound that, when oxidized in the atmosphere, helps shape the clouds above and influences the planet's entire ecosystem. If DMS is truly present in the atmospheres of exoplanets like K218b, it could be a game-changer in our search for extraterrestrial life. Yet, the potential detection of DMS on K218b is still under careful study and rigorous testing. With the advanced mid-infrared spectrograph aboard James Webb, we have the power to eavesdrop on these complex molecules. But confirming their presence demands meticulous analysis and the sharpest expert judgment. The discovery of potential biosignatures, like DMS at K218b, has ignited a wave of excitement in the global scientific community. But, as with any groundbreaking discovery, it comes wrapped in challenging questions. If it were you, would you believe that a single, humble molecule could trigger an earthquake in the history of our search for life? The discovery of DMS on K218b has ignited a debate that sways between icy skepticism and blazing optimism. The scientific community stands divided over the true significance of DMS. Some hail it as a golden candidate for biosignatures, while others warn that abiotic processes can just as easily give rise to such compounds. This ongoing debate only highlights the tangled web of complexities and daunting challenges that come with interpreting data from distant exoplanets. Throughout history, astronomical breakthroughs have always faced the glare of doubt. When Galileo first glimpsed the satellites of Jupiter, his discoveries were dismissed, even scorned, by the scholars of his time. Similarly, when the first exoplanet was announced in 1995, the scientific world greeted it with caution, wary of bold claims. These echoes of history remind us that skepticism is an essential companion on the journey to truth. The search for extraterrestrial life doesn't hinge on a single molecule or one fleeting observation. Scientists tirelessly piece together the puzzle, assembling clues from DMS, methane, to water vapor, hoping to paint a picture convincing enough to hint at life beyond our world. Is DMS simply a question mark? Or could it be the keystone in a much larger, mysterious mosaic? The debate will surely continue until... As new data streams in and technology surges forward, future missions armed with even more sensitive instruments may provide the proof needed to classify DMS as a true biosignature. Is DMS the long-awaited key in our quest for alien life, or just a mirage leading us astray in the cosmic labyrinth? Whichever answer awaits, the debate itself stands as a living testament to the restless spirit of science. A world where every question births 1,000 pathways, where each discovery is another step bringing us closer to the horizon of knowledge. The James Webb Space Telescope has revolutionized our understanding of distant worlds, like K218b. Yet it is only a small step in humanity's never-ending journey through the universe. What lies beyond this monumental milestone? How far will future technologies push the boundaries of our cosmic horizons? The extremely large telescope, scheduled for completion by 2025, promises to spark a new revolution. With its main mirror spanning an astounding 128 feet, set to be the largest near-infrared optical telescope ever built. Its unmatched sensitivity could either confirm or dismiss the biosignatures that James Webb has glimpsed. And the mission known as the Large UV Optical IR Surveyor, or LUVOIR, continues to paint new dreams on the canvas of humanity's imagination. On the horizon of exploration, ambitious projects like LUVOIR promise to complement and illuminate James Webb's discoveries. Engineered to scan a vast spectrum of wavelengths, LUVOIR can provide atmospheric analyses with unprecedented detail and may even capture direct images of alien worlds. As humanity sets its sights on ever more distant exoplanets, advances in propulsion technology become the ultimate key. Breakthroughs like ion propulsion, or even the tantalizing, still theoretical dream of antimatter engines, offer the hope of slashing travel times, letting probes reach and study exoplanets within a single human lifetime. We've previously released a video exploring the prospects and immense challenges of interstellar travel. Standing at the threshold of discoveries that could shake the very foundation of our civilization, perhaps it is time to pause and reflect on the philosophical questions and deeper meanings that ignite our cosmic curiosity. How might the search for extraterrestrial life transform our sense of existence, or reshape the questions we ask about our future? One question now rising to prominence is the role of red dwarfs in the galaxy. Could these countless, humble stars Red dwarfs, so often overlooked for their modest size and faint light, could they truly be the cradles of life? Their remarkable longevity and unwavering stability make them some of the most compelling candidates for life-bearing planets. What would the discovery of extraterrestrial plankton mean for our understanding of life? Such a revelation would not only confirm that life exists beyond Earth, but would also suggest that the very building blocks of life are more universal than we ever imagined. Have you ever wondered what marvels the next decade might unveil on our journey to understand the cosmos? Will we finally confirm the existence of life beyond Earth? Or will we stumble upon new mysteries, even more intricate and confounding, that force us to rethink everything we know about the universe? If it were you, would you choose to believe in miracles? Or would you be the one who never stops questioning? Share your thoughts below, and join us as we chase the answers in the next chapter of this cosmic story. If this cosmic story has touched your imagination, don't hesitate to hit the like button, share your thoughts in the comments below, and spread the wonder of discovery by sharing this video with others. And remember to subscribe, so you'll never miss a step as we continue unraveling the universe's greatest mysteries together.